Hi, my name is Mack. I'd like to present you a role object pattern. Now, what is role object pattern? The role object pattern suggests two model context-specific views of an object as separated role objects which are dynamically attached to and removed from a core object. Role object is a design pattern used for executing type migration in a language which doesn't have it. It uses common features on the host object with a separate object for each role. Clients ask the host object for the proper role to use a roles feature. As is shown on the figure 1, this is a customer hierarchy in a banking environment showing how the hierarchy works on for the system, whereas for the customer it has the accounts, the add role, and the get role, or who the customer is. As for customer core and the customer role have each its own variables what it needs to get in order to have its roles within the hierarchy for the banking system. For the intent of role object, it adapts the object to different clients and needs through clear binding role objects. Each one representing the role the object has to play in that client's context. With roles playing parts as individual objects, different contexts remain separate in system configuration to make it simple. Now, what's the motivation behind a role object? The motivation for this object-oriented system is typically based on a set of key abstractions. Each key abstraction is modeled by a corresponding class in terms of abstract state and behavior. This usually works fine for the design of smaller applications. However, once we want to scale up the system into an integrated suite of applications, we have to deal with different clients that need context-specific views on our keys abstractions. Suppose we are developing software support for the bank investment department. One of the key abstractions to be expressed is the concept of customer. Thus, our design model will include a customer class. Class interface provides operations to manage properties like the customer's name, address, savings, and deposit accounts. Let's assume that the bank's loan department also needs software support. It seems our class design is inadequate to deal with a customer acting as borrower. Obviously, we must provide further implementation, state, and operations to manage the customer's loan accounts, credits, and securities. Integrating several context-specific views in the same class will most likely lead to key abstractions with bloated interfaces. Such interfaces are difficult to understand and hard to maintain. Unanticipated changes cannot be handled gracefully and will trigger lots of recompilation. Changes to the client-specific part of the class interface are likely to affect clients and other subsystems or applications as well. So basically, for the interfaces, it needs certain operations for it to work, and the operation doesn't implement correctly on what it needs for certain objects, then things could go wrong. So it needs to be maintained just for the clients of the interface. So nothing could go wrong when the for the keys abstraction on what it needs. Well, such as customer's information in the customer's loans within the account. But there's more for the role object. A common example is given in employee types concerning the need to promote an employee for a programmer to a manager. If a OO system programmer and manager are different types / classes, how is this done? With roles object, we create a wrapper object which clients use. We then set up various role objects like programmer role and manager role, which represent the actual functionality of the specific roles. Changing the employee type requires replacing programmer role with the manager role. Now there's applications of the role object. that I'd like to discuss. You want to handle a key abstraction in different contexts, and you do not want to put the resulting context-specific interfaces into the same class interface. Also, you want to handle the available roles dynamically so that they can be attached and removed on demand. That is, at runtime, rather than fixing them statically at compile time. You want to treat the extensions transparently and need to preserve the logical object identity of the resulting object conglomerate. You want to keep role/client pairs independent from each other so that changes to the role do not affect clients that are not interested in that role. So basically, for the applicability of the role object is just for the key abstractions. You want to put them in the same class interface because otherwise you won't know which class is is referring to when using it for the key abstractions. And just for on the roles, says its goal for fixing it. It needs to be removed. I guess once it's been attached when it's going on runtime, and just for the roles and clients in general, just on the application, they need to be independent. They don't need to depend on each other because they be dependent to one another. Then well, basically, it won't have no role to fulfill, and well, it won't fulfill its duties on what it's been assigned to. Okay, so on the class diagram of role object, you have different objects that's been assigned to different roles, where you got the investor role, where it has a amount to invest, tells on how much the investor wanted to invest in money. There's a name, well, who the investor is. Then there's variables, the other stuff that's under the investor role. Then for the borrower role, same thing, but also have this all information of the borrower, and the investor and the borrower goes to the customer role on who the customer is. Then it goes on to other information on what the customer core has or what it needs for each information, such as the customer report, the add role, get role, hash role, remote role, and the to string just for the role of the customer report. Then the customer gets the information, everything that's under the object of the customer, just from the other object that points to that object. Now for role object patterns, it always has participants with the roles or for each object. There's a few that's in that. So first is the component, which a customer will use, for example, models a particular key abstractions by defining its interface, specifies the protocol for adding, removing, testing, and inquiry for role objects. Client supplies a specification for a concrete role subclass. In the simplest case, is identified by a string next to the component core, which the customer core is, implements the component interface, including the role management protocol, creates a concrete role instances, manages its role objects, next is the component role, which is the customer's role, stores a reference to a decorated component core, implement the component interface by forwarding requests to its core attribute. And last is a concrete role, which is the investor and the borrower is. Models and implements a context-specific extensions of the component interface can be instantiated with a component core as an argument. Reasons for role object it is common practice to implement roles such as employee, customer, etc. as subclasses of a common role player class such as person. However, this means that different instances of the role classes are actually different objects with different state and different identity, even if they are meant to represent the same logical entity. The role object pattern addresses this problem by representing an object in its roles as a composition of one role player object called the core, arbitrarily many role objects. this sample code that I got of the role object supposed to demonstrate how it works for the role object. So the following code demonstrates how to perform customer example that was explained in the motivation section. We'll assume there's a component class called customer. Here the class customer role has been assigned as a class, and there's another class that is customer. Then they have the public, and under the public they have the virtual variables with the get accounts. Then next you got the virtual customer roles that's been assigned from the customer role. Then the variables created was a get role. Next is an add role, move role, and hash role. And there's more codes to it for the sample of the role object. On the next is a class customer card that uses customer for the public classes. Under the public, got the customer role, get role, string a spec. Then after, you're supposed to return the roles a spec. Then you got the next one, the customer's role times add role, and each one have its own implementations of what it's doing filling their roles for each object. This been seen just on the sample code. Then the uses of the sample code, the specification of a role is applied as string, which equals the class name of the concrete role class. The mapping between the role's description and the role object is executed by dictionary. Next, we define subclass of customer called customer role, which we will have a subclass to acquire different concrete roles. Customer role decorates the customer core referenced by the core instance variable for each operation in customer interface. Customer role forwards the request to core. Notice that the core instance variable is typed as customer core, thereby ensuring that customer roles are not used as core object. There's another sample code that I just picked up in a copy and paste with the Balmer's plus 97. The mapping between a role's specification and an appropriate creator object is able to essentiate the specific role is implemented as a lookup table for a detailed discussion of how to implement and manage creator objects. See Boomer plus 97. So here the class customer role it's been assigned with the public customer, and on the public you have the dynamic link list that's been assigned link account. Then there's a get accounts. Then it returns the core to get accounts. Then right under it got the customer role signs an add role. When the perimeter of the add role, there's a string a spec. Then it returns the core to the add role. Then the rest goes on, where each one returns its own variable to its own core. Then further down, you got customer role times new role equals null, meaning where once it fills its roles, then it becomes null after. Then it gets to the if statement where there's a new role, creates a new role for the A core. If it's not a new role, then it returns the new role. Then the customer core times core has been assigned to the private where it can't be accessed by anything outside of it. So there's part 2 of the sample code of the role object with Balmer's plus 97. Subclasses of customer role define specific roles. For example, the class borrower as operations to handle securities in credit accounts. Subclasses do not override the inherited role management operations. So the class borrower is assigned to the public customer role. Under the public, it's also have this linked list, list security, get securities, and returns securities. Then there's a the private variable list security. Those that clients must downcast the role reference returned by the core component before they can invoke role specific operations on the role instance. So then there's a customer times a customer database, load com zones, bar times a bar equals null. So then it'd be where if a bar equals to dynamic cast, it'll get the role of the customer. There'll be where there it'll have access to the security if it's the right the borrower what it needs. So if it's not the bar that's asked for, it doesn't match the customer's name, then the access will be denied. That's what the security is made for, just to get the info of the bar. And here's where I get the most of the information in the sample codes and the diagrams of my references of the role object. So that's pretty much it with the role object patterns on what needs to be discussed, what I want to present. So if there's any questions that needs to be addressed or if something needs to be explained some more, I'll be happy to help. And that's all I want to present, the role object pattern.